Now in the instructions here for number 22, it just kind of says to solve for x, but it doesn't really tell us anything about these two triangles, but we should know that they are similar actually. So these two triangles here are similar, which means we can set up two proportions in order to solve for our missing variable. So I'm going to start here with this side length of 9. 9 is similar to the side length of 5. And then I'm going to pick another side length here that only has one variable in it for both of them. So I'm going to choose here this length and this length here. So my hypotenuse in both of those, assuming that these are both right triangles here. So I'm going to have that 3y minus 12 is divided by y. Now I chose this one because, well, you could have chosen the x one too. We're going to have to here in a second, but let's go ahead and cross multiply here and solve. So I'm going to get 9y equal to 15y minus 60. Go ahead and pause this, solve your answer, and unpause to check your work. So we should have gotten that y equals 10. Now we're going to go ahead and set up another proportion so that way we can solve for x. So I could go ahead and set up 2x plus 1 over 7 is proportional to 9 over 5. Now this time I did not choose my ones with y's because I don't want there to be two variables here. So only choose one variable at a time when you're setting up your equation here. So go ahead and cross multiply and solve. Go ahead and unpause this video to check your answer. All right, you should have gotten that x equals 5.8. If you made a mistake here, I'm guessing that it was because you didn't multiply 5 times the entire quantity of 2x plus 1. So you got to make sure you're distributing that 5 to both terms there if you have more than one thing in the numerator. And then go ahead and just solve like a regular algebra problem here. Moving on to number 23. Number 23 here, we are going to have to use another theorem that we learned in section 7.5 called the corollary to the side splitter theorem. So if we have three parallel lines here, which is what those little tick marks mean, these little things right here say I have parallel lines. If it's intersecting two transversals, then the segments intercepted on those transversals are proportional. So we can go ahead and say that this proportion here, that segment length is proportional to 5. So 12 divided by 5 is going to be equal to, since we started with 12, we can't start with 6. We got to start with x in the top, x divided by 6 here. Then we just go ahead and cross multiply and solve. Go ahead, pause this video, and then unpause it to check your work. And we should have gotten 14.4. Moving on, number 24. Instructions for this section say determine whether the triangles are similar. If so, write the similarity statement and name the postulate and theorem used. If not, explain. So we got to see and decide, are these two triangles similar? Well, I've got these two pair of parallel lines, and I know that if a transversal cuts through two pairs of parallel lines, that these angles are congruent because of alternate interior angle theorem. Similarly, we can also say that these angles here are congruent by vertical angles. And if we know that the two angles are congruent in the other two angles of the triangle, we know that that third angle is going to be congruent. But do we need that third angle to prove that two triangles are similar? No, we only need two angles. So our postulate that we're going to use is angle-angle similarity. That little tilde means similar. And then we just got to be careful when we're labeling. If I start with W-A-H, since I started with W first, I'm going to start with T in my second triangle. T-A-S. Just got to be careful labeling it. Number 25. Now we're given no angles, but we're giving some side lengths here. We got to check and see if all of my side lengths have the same proportion. If so, then they will be similar by side similarity. So we've got 8 corresponds to 6. We're checking, does that equal 12 over 9? And does that equal 16 over 12? You always have to start with the same triangle every single time. Well, all of these are going to simplify to give me 4 over 3, every single one of these. Okay, so since they are the same, we can go ahead and say that these two triangles are similar by side similarity, and now we just have to label the triangles. So ABC, since I started on the top here, I got to start on the top here, so X, Y, Z.